Hello, welcome back. Today we are going to move on to the fourth chapter, which is force, density, and pressure. And the first thing is turning effect of forces, right? So, the first learning outcome you need to know about is the center of gravity. The definition is as follows, and you should memorize this. Uh, the single point on which all of an object's weight seems to act, right? So this definition is tested quite often, and you should know this definition by heart. uh, Now moving on to moment. Define and apply the moment of force. So the product of force applied and its perpendicular, right? This is very important. It's perpendicular distance from the pivot, right? So the formula is moment is equal to F into D, where the distance is the perpendicular distance from the pivot and F is the force applied, right? Or at least the vertical component of the force applied, or horizontal based on the scenario. But you'll see these in the next couple of videos. Now, to understand moment a little bit better, moment is basically, you probably know this already, but moment is basically this, right? A force is applied, a pivot is present, right? So a rotational force is obtained instead of a straight downward motion, right? So that is what moment is all about. Torque, you can also call it torque, but basically that's the whole concept. And that's all you need to know to solve all your questions in the papers, right? Now, a thing that you might not know is a couple, right? So what basically is a couple? Let me just draw a nice circle here. F, right? Its magnitude is F, and the same force is here, and the magnitude is F. Now, this is basically a couple, and you can see that it is producing an anti-clockwise moment, basically, of this circle here, right? So this is basically a couple. When two forces of equal magnitude and opposite direction are applied on different lines of action, right? They can't be applied on this line. You can see that if they are being applied here on the same line of action, right? So the moment will not be produced, and this force will not be considered a, a couple. You can take this on any point of the circle, basically. For example, if the second force was being applied here, this would also not be a couple because it's in the same line of action. So the requirements are same magnitude, right? The forces must be of same magnitude to make a couple. Opposite direction, obviously, otherwise the object would not rotate. And different line of action, right? This is also very important. So basically, this is a couple. And now I'm going into the formula. So this distance is not D, right? This is the pivot, basically. Center of motion, center of rotation. This is the pivot. So this would be D, but this distance would be written as, denoted as S, right? So let's just move on. Definition would be the product of magnitude of one force and the perpendicular distance between them. So in the couple, the distance that you take is not d, right? Like in normal moment, but s, right? And if you want the logic, I'll also tell you the logic now. The moment of a couple or the torque of a couple is equal to one force, the magnitude of F, right? In this scenario, into S, right? So look at this diagram if you're confused about this. Now, why is a moment of a force F into S, right? So basically, the total moment that these two forces are applying here is F into D plus F into D, right? And this becomes 2F into D, right? Easy algebra. And 2D is basically S, is equal to S, right? This is half S and this is half S because they're at the same distance from the pivot, right? So 2D becomes S and this becomes moment of a couple. So this is a derivation that will not be tested, but if you were curious, you now know why this is S and one force only when there are two forces being applied, right? So this is basically it for moment. There are a little bit of nuances, but we'll tackle them in the past papers. So don't worry about them right now. Just memorize these definitions and you're good to go. Thanks for watching. Goodbye.